Good afternoon, this is Keith Capellaro, K-Dawg Weather. Today, I'm going to be talking about understanding ENSO, the El Nino-Southern Oscillation, and its global impacts. The agenda overview for today is Introduction to ENSO, Physical Mechanisms of ENSO, ENSO Phases and the Characteristics, Global Impacts of ENSO, Monitoring, Prediction, and Adaptation Strategies. Introduction to ENSO. Definition and significance of ENSO. ENSO climate pattern. ENSO involves temperature shifts in central and eastern tropical Pacific waters coupled with atmospheric pressure changes. Global weather impacts. ENSO strongly affects global weather patterns including rainfall, temperature extremes, and storm frequency worldwide. Ecosystem and economy effects. ENSO influences ecosystems, agriculture, and economies, making monitoring essential for climate variability management. Components: El Nino and La Nina. El Nino characteristics, it's right here, causes warmer eastern Pacific sea temperatures, weakened trade winds, and altered atmospheric patterns. The La Nina characteristics features cooler sea temperatures and stronger trade winds in the Pacific. Global weather impacts. Both phases influence global weather, causing droughts, floods, and changes in tropical storm activity worldwide. Importance for climate prediction. Understanding El Nino and La Nina is essential for predicting climate impacts and preparing for weather extremes. Historical context and discovery. Early observations. Fishermen historically observed warm waters off South America, naming it El Nino, and documenting recurring phenomena. Scientific discoveries. Researchers in the 1960s and 1970s identified ocean-atmosphere interaction critical to ENSO behavior and dynamics. Climate prediction evolution. Understanding ENSO mechanisms led to the development of advanced climate prediction models used today. Physical mechanisms of ENSO. Ocean-atmosphere interactions in the Pacific. The role of trade winds. Trade winds control ocean currents and sea surface temperatures, influencing ENSO development. Sea surface temperature anomalies. Ocean temperature anomalies feed back to altered atmospheric circulation, driving ENSO patterns. Atmosphere-ocean coupling. Coupled ocean-atmosphere shifts in convection and pressure define ENSO events. Complex climate pattern. ENSO operates across diverse spatial and temporal scales, making it a complex climate phenomenon. Changes in sea surface temperatures. ENSO and SST fluctuations. ENSO events cause sea surface temperatures to rise or fall significantly in the Pacific Ocean during global weather patterns. El Nino temperature increase. El Nino raises SST by 0.5 to 3 degrees Celsius above average in central and eastern Pacific regions, impacting climate worldwide. La Nina temperature decrease. La Nina causes cooler than average SSTs in the Pacific, altering typical weather and climate pattern globally. Satellite tracking of SST. Satellite data since the 1980s have improved tracking of SST changes and revealed ENSO spatial and temporal evolution. Shift in atmospheric pressure patterns. The Southern Oscillation Index. SOI measures atmospheric pressure difference between Tahiti and the Darwin tracking ENSO phases. El Nino conditions. Negative SOI values indicate El Nino characterized by weakened trade winds and altered weather patterns. La Nina conditions. Positive SOI values indicate La Nina featuring strength strengthening trade winds and intensified weather phenomena, global weather impacts. ENSO shifts influences monsoon strength and cyclone activity worldwide, affecting global climates. ENSO phases and the characteristics. El Nino events and features and impacts. El Nino occurrences and duration. El Nino events occur every 2 to 7 years and last about 9 to 12 months, impacting global climate patterns. The weather disruptions. Weakened trade winds and warmer Pacific sea surface temperatures causes rainfall changes, drought worldwide. Economic and social impacts. El Nino leads to crop failures and increased wildfire risk, affecting economies and communities globally. La Nina event features and impacts. Characteristics of a La Nina. La Nina features stronger trade winds and cooler sea surface temperatures in the Pacific Ocean. The weather impacts. La Nina causes increased rainfall in Australia and Indonesia and droughts in the southeastern United States. Hurricane season effects. La Nina intensifies the Atlantic hurricane season, increasing storm frequency and strength. Global influences and frequency. La Nina events occur every 2 to 7 years, impacting agriculture, water resources, and disaster patterns worldwide. Neutral and phase transitions. Neutral phase characteristics. The neutral phase features near-average Pacific sea surface temperatures and atmospheric conditions between ENSO events. Transition dynamics. Transition between ENSO phases can be abrupt or gradual, making prediction challenging for meteorologists. Importance of monitoring. Monitoring neutral conditions help detect weak ENSO signals that influence regional climates and support risk management. Global impacts of ENSO. Influence on weather and climate patterns. Global atmospheric circulation. ENSO alters global atmospheric circulation, impacting temperatures and precipitations across continents worldwide. Regional weather effects. ENSO influences monsoon behavior in Asia, drought frequency in Africa, and winter temperatures in North America. Extreme weather events. ENSO-driven climate anomalies contribute to extreme weather events with effects lasting months after peak intensity. Effects on agricultural system and ecosystem. Agricultural impacts. ENSO causes drought during El Nino and flooding during La Nina, disrupting staple crop production and globally. Ecosystem stress. Ocean warming from ENSO events damages coral reefs and changes fisheries due to altered upwelling patterns. Food security risks. ENSO-induced climate variability threatens global food security and biodiversity through agricultural and ecosystem disruptions. Social, economic, and consequences. Disruptive livelihoods. ENSO causes top failure and fisheries decline, severely impacting people livelihoods worldwide. Natural disaster costs. Increased floods and wildfires from ENSO events lead to high economic and social costs. Economic and health impacts. ENSO-induced climate extremes cause insurance losses, reduce GDP growth, and health changes globally. Monitoring, prediction, and adaptation strategies. Technique for monitoring ENSO. Ocean buoy network. Ocean buoys like TAO/Triton area collect crucial data on sea surface temperatures and current to monitor ENSO. Satellite remote sensing. Satellite measures sea surface temperatures and wind patterns to provide comprehensive data for ENSO tracking. Climate model data assimilation. Interrogation of observational data into climate models enhance early warning systems for ENSO impacts worldwide. Challenges in forecasting ENSO events. Interistic variability. ENSO forecasting is complicated by the natural variability in the ocean atmosphere system, making it predictions difficult. Data limitations. Limited and incomplete data restricts the accuracy and leads time to ENSO event forecast. Model uncertainties. Uncertainties in climate models affect the predictive skills of ENSO forecasts, especially for weak or rapid events. Importance of actual forecasts. Reliable ENSO forecasts are essential for disaster preparedness and managing natural resources effectively. Adapting and mitigation approaches. Adaptation strategy. Improved water management, climate-resistant farming, and disaster plans tailored to ENSO forecast enhance resilience. Migration efforts. Enhancing early warning systems and interrogating ENSO data into policies help reduce climate risk efficiently. Public awareness and cooperation. Raising public awareness and fostering international cooperation are crucial to minimizing ENSO vulnerabilities. And as we conclude, ENSO's profound influence and the path forward. What we learned: global impacts of ENSO. ENSO influences global weather, ecosystems, and economies through its El Nino and La Nina phases. We also learned understanding ENSO mechanisms. Studying ENSO's physical mechanisms improve monitoring and prediction of its events. And finally, adaptation and mitigation. Advancing adaptation strategies is vital to reduce ENSO impacts and protect the vulnerable communities. This is Keith Capellaro with K-Dawg Weather, and I want to thank you very much. Please like and subscribe to this channel. Thank you, and have a wonderful day.